Hello everyone, my name is Sanjeev, and today we're going to be looking at stat math, problem solving, and data analysis problems. More specifically, your one variable data distributions of distributions and measures of center and spread. And as always, we have a set of 5 hard difficulty questions. So the first question states, the box plot summarizes the masses in kilograms of 2 groups of gazelles. Based on the box plots, which of the following statements must be true? The mean mass of group 1 is greater than the mean mass of group 2. B, the mean mass of group 1 is less than the mean mass of group 2. C, the median mass of group 1 is greater than the median mass of group 2. And D, the median mass of group 1 is less than the median mass of group 2. All that sounds really confusing, but first we have to start by analyzing our box and whisker plot. So we have 5 lines, right? First is this one, second's this one, third's this one, fourth's this one, and fifth's this one right here. So what do these lines represent? Our one that is furthest to the left represents your minimum value in your data. Your second line right here represents your 25th percentile or quartile. Your third one right here represents your median value. Your fourth one right here represents your 75th quartile or percentage. And then your last one right here is your maximum value. And also the box is called the interquartile range, or the range between 25 to 75%. So now if we look at our questions, we see that option choices A and B all talk about comparing mean masses. And nowhere in our description of our box and whisker plots do we mention mean. So we can immediately cross those out. Instead, we're dealing with median. If we look here, our median value is going to be this one, right? And looking clearly, we see that we have in group 1 a median mass of 25 kilograms. And in group 2, a median mass of 24 kilograms. Group 1 has a greater median mass than group 2, so that's just option choice C. And as I said earlier, this problem it seems really hard, but all you need is a basic understanding of your box and whisker plots. To do that, you just need a lot of practice, and you'll eventually get it. However, right now we're going to launch our second problem. Our second problem states that dataset A consists of 10 positive integers less than 60. The list shows that 9 of the integers from dataset A, and then these are your 9 integers. The mean of these 9 integers is 42. If the mean of the dataset A is an integer that is greater than 42, what is the value of the largest integer from dataset A? Well, what do we know? So we know that these 9 integers are part of set A, and they have a mean of 92. And we also know that dataset A, which has one extra value, has a mean that's greater than 42. So what is mean? If you guys don't know, it's the average. We're going to total up all of our data value. So that would be 43 plus 45 plus 44, etc. Right? And then we're going to divide it by the number of values. So we have 43 is 1, 45 is 2, 44 is 3, so on and so forth. And we have 9 integers. So in this case, it would be 9. And then this would be equal to 42. Right? So one interesting fact about mean is that if we know that the mean of a certain number of elements, which is in this case 9, is a number, which is say 42, if the number that's added, say we add the number, 38, okay? The mean will be dropping because our value of 38 is less than our previous mean, right? Moreover, say we add a value of 90, right? Our mean will actually become larger because we added a value that's more proportionately larger. Moreover, if we add the value 42 again, then what will happen is the mean will stay the same. And remember, when we're adding a value, the total data will have an increase of 42. Say if we included 42 as a value, and this will also become 10. So what do we know? We know that if the mean is 42 in here, in our 9 integers, and the mean of dataset A is greater than 42, that means that we're including a value that is greater than 42. Right? And say our value is x, and we know that it has to be, less than 60. because it says dataset A consists of 10 positive integers less than 60. So now, what do we do? Well, we know that the mean of data set A is an integer, right? It's not a decimal, it's not anything. So what can we have here? So we need to say we have 10 values. Wait, this is what I'll do. Yeah. So say we have 9 values, right? So we have 9 times 42 will be our previous number. Okay, so that would be 378 will be our total of our 9 integers. Plus x. Okay, divided by 10. Because remember, we now have 10. And then this should be greater than 42. Right? And since we are only having integers, and yeah, we'll have 378 plus x will be greater than 420. And x, in this case, will be equal to 52. And is 52 greater than 42? Absolutely. So we just have found our answer. So our answer is just, 52. Moving on to our next question. Our next question states, a data set of 27 different numbers has a mean of 33 and a median of 33. A new data set is created by adding 7 of these, by adding 7 to each number in the original data set that is greater than the median, and subtracting 7 from each number in the original data set that is less than the median. Which of the following measures does not have the same in both the original and new data sets? Okay, so what do we know? So we have a set of 27 numbers, right? So, okay, let me actually do it this way. Say we have, okay, yeah. Say we have 27 numbers, okay? And say they're all, you know what, let me do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, I don't know if that's actually 27, but I hope it is. Okay, so if you have 27 numbers, right? Say all of the say the middle number is x. Okay. Okay, so wait. Let's put it this way. So if we have 27, right? What is our median? It's our middle number. So in this case, it'd be number 14, right? Number 14 would be our median. Number 14. So, well, by number 14, I mean like slot number 14. Like, if this is slot 1, slot 2, slot 3, so on and so forth. Whatever the 14th number in our list is, say it's x, that would be our median number. Okay? And say the previous 13, 1 through 13, it has a value of x minus 1. Okay? And say 15 all the way to 27, right? One sec. Yeah. Say the numbers 15 to 27 all have the number x plus 1. Okay? Well, what will happen, right? We have a new data set that is created by adding 7 to each number in the original data set greater than the median and subtracting 7 from each number in the original data set that is less than the median. Okay? So what would be the new set would be, we'd have numbers, number 14 will still say x, right? Because that's not being changed. Only the numbers before and after are being changed. Numbers 1 through 13 will have the values of x minus 1 minus 7. Numbers 15 through 27 will have the values of x plus 1 plus 8. Plus 7. Right? And then this will be just, x minus 8 and then x plus 8. So you already know that the median is going to be staying the same because it's still x, right? And what else do we know? Well, we have the same number of elements, okay? and the same number, well, we have the same number of elements, which is going to be 27. So that means that if we know that our mean is equal to our sum of the numbers divided by the number of numbers, right? Since the number of numbers is going to be staying the same, if the sum of the numbers is the same, then median automatically means it's the same. And if, the mean automatically means that it's the same. And if the mean's the same and we have the same number of numbers, then the sum is also going to be the same. So we can eliminate these two as well. However, another way to look at it is, say we have 1 through 13 x minus 8, okay? 1 through 13 x minus 8, so that would be x minus 8 times 13, right? And then plus, this is supposed to be x plus 8, not x plus 18. X plus another 13 of x plus 8, right? Plus x. That would be our total. This would be equivalent to 13 x plus 1s plus x plus 13 x minus 1s, right? What we can do to figure this out is simply distribute it, and we'll find out that the sum would be the same. And our mean will just be this value divided by 27, right? And then here too, we're just going to be dividing that by 27. If you just distribute all these x's out and our parentheses, we'll find out that this is the same. So what is standard deviation? Standard deviation is simply how spread the data will be. So in our previous example, we'll have 1x plus 1 and say 13x plus 1s and 13x minus 1s. After our transformation, we'll still have 1x plus 1. However, you'll have one that's super far away, right? Because it's now x plus 8, and that's one that's super far away, which is x minus 8. So it's getting more spread out. So that means that the standard deviation will change. This might have been kind of confusing, but I hope that you understand this one. Next one is the dot points plots represent the distribution of values from dataset A and B. Which of the following must be true? The median of dataset A is equal to the median of dataset B, and the standard deviation of dataset A is equal to the standard deviation of dataset B. Okay, so in case you guys were wondering, I was using this dot plot for our previous question right here. I just didn't do the dots because it would take too much time to individually hand dot all of them. But what is the median? We know that the median is our middle number, okay? So if we have 5, 7, 10, 12, 16, 17 data points, then that means that number 9 would be our median number. So 1 plus 4, 5, 5 plus 7. So this dot right here, this dot right here would be our median. And right here, it would be this dot right here, that's the median, okay? So if we look at this, we see that the median value is going to be 13. So that means that the median of set A is equal to set B. Okay, the standard deviation is how spread out it is. You might say, the range is still the same, right? It's still 10 to 16. There is a difference, however. Here we see that there's only one value for 10 and one value for 16. However, here you can see we have two values of 10 and two values of 16. That means that statistically, dataset B is actually a bit more spread out and has a higher standard deviation than set A. So this would be an X. So our answer is A, which is 1 only. Okay, moving on to the next problem. The table shown summarizes the number of employees at each of the 17 restaurants in a town. Which of the following could be a median number of employees for the restaurant in this town? Okay. So remember, what do we do to find the median? Our median is our middle number. Okay. So what do you know about this table? So we know that the number of restaurants with 2 to 7 is 2, right? So you have 2 plus 4 plus 2 plus 7 plus 2, right? And that's equal to 6 plus 4, which is 10 plus 7, 17. So our median value will be our, say, 9th point. Okay, so 2 plus 4 is 6. 6 plus 2 is 8, right? 8 plus 2 is 15. So that means it has to be within the 20 to 25 range. And the only one that matches that would be D, which is 21. And that would be our answer. A lot of these questions right here that I showed you today might seem really complicated, but what you need to do to solve these types of problems is simply just practice. If you know our basic values, like how to find mean, how to find median, how to recognize how to do standard deviation, because in the SAT you're not expected to calculate the actual value of standard deviation. Instead, you're just expected to look at the graph and see which one's more spread out. And moreover, if you know how to analyze your graphs a bit to a decent extent, you can solve most of these problems. So that's what I would suggest that you need to do in order to practice for this level of problems in your SAT math. And that's all for today, and thank you all.